Sound good?
Yeah.
All right. I got an alarm set, so we won't miss it. This is not my normal presentation that I give. I normally just talk. So if I wander off of this, forgive me. We're trying to put together AmSat is trying to put together a single set of presentations for different audiences, and this is the first time I've used it. I went through it this afternoon and found some errors in it, so we'll talk about those when we get to it. And I didn't get the clicker. Willem, will you get the clicker from the gentleman in the back, please? Just by show of hands, who in here has worked a satellite before? Made a satellite contact? All right, so we got 5, 6, 7 guys and gals that have done this. So, okay, we're going to go over just some basic terms so that when I'm talking about them, you'll know what I mean. There's a couple of different types of orbits we talk about. Circular orbits and elliptical orbits. And it's real simple, it's just what it sounds like. A circular orbit is pretty much a circle or close to it. An elliptical orbit is more egg-shaped. So when it gets out to the high point called apogee, it's a lot farther from the Earth and sees more of the Earth. Right now, a couple of them that are a little bit elliptical, but what that means is that their footprints stay pretty close to the same range that you can talk with them. So I mentioned it, apogee is the high point, and perigee is the low point, where it's closest to the Earth. And you'll hear these terms come up and down. Hey, I worked Europe on FO29 at apogee. That means it was at its highest point. Satellites have inclinations. They travel in a circle around the Earth in orbit, but how that circle is oriented is the inclination. If it's straight up and down, pole to pole, that's a 90-degree inclination. If it's at 45 degrees, that's a 45-degree inclination. If it's this way, along the equator, it's a 0-degree inclination. Most of our satellites are high inclination, 90, 98. Some of them go actually past 90, and that makes it where they come over about the same time every day. That's called a sun-synchronous orbit. All of our satellites right now over the U.S., I have to add that caveat now, are low Earth orbit. That means they're relatively close to the surface of the Earth. They're not very high. The International Space Station is in low Earth orbit. All of the satellites that we're using right now are in low Earth orbit, except there's a payload that was just launched on SHIO-2, which is a Qatari TV broadcast satellite. It's parked over Africa. We can't. It has a 2 gigahertz up, 10 gigahertz down, 2 transponders on it. Unfortunately, where that satellite's, that's an AmSat Germany project, where that satellite's parked, we won't be able to see it from here. If you went all the way out to the very tip of Newfoundland, you might get a 1/10 of a degree. But for us here, it's below the Earth. In the past, we've had high orbit satellites. Anybody that's worked Oscar 10, Oscar 13, or AO40, those were high orbit satellites in very elliptical orbits. So when they go out at apogee, they basically cover half the Earth. And unfortunately, we don't have any of those right at the moment. All 3 of those were launched on test flights of the Ariane launch vehicle. It's now part of ESA. And the space on the launch was basically a gift to AmSat DL and AmSat NA, and they're not doing that anymore. If we were to go out and purchase a launch to HEO, the numbers for a HEO-sized satellite are now anywhere from $5 to $10 million. And so far, we have not found a path to finance that from the amateur community. So that's why we don't have any high orbit satellites right at the moment. We're still looking. We'd like to go there. We almost went there with a military payload a couple of years ago, but the satellites we're going to be talking about are in low Earth orbit. So you'll hear people talk about telemetry. Telemetry is just information from the satellite coming down, usually by itself. Sometimes it's requested by a ground station. It can be Morse code. It can be 1200 baud packet. It can be 9600 baud packet. It can be 1200 baud BPSK. There's all sorts of newer formats that are being tested. LORA, LORA, which is a spread spectrum type of system that's being tested on some new satellites. But that just tells you things: voltage, what's the temperature, have you had any upsets where the computer crashed, things like that. Uplink and downlink, again, just basic terms. Uplink is when you're talking to the satellite. Downlink is when you're listening from the satellite. So if I say it has a 2-meter uplink, that means you're transmitting on 2 meters up to the satellite. If it has a 70 centimeter downlink, you're listening on 70 centimeters to the satellite, the signal coming down. Make sense?
Yeah.
All right. Yeah. Of course, my son says, yeah. Talking about that. So, while there are plenty of satellites up there that just have telemetry beacons, for one reason or another, usually university projects, things like that. Personally, I'm interested in a satellite that I can make contacts through. So I have an uplink and I have a downlink. And you have the same uplink, or you may be coming up on a different band on some of the larger satellites. Back up a second. Think of it like a repeater. You have a repeater transmit frequency and a repeater receive frequency. Now that's on FM. That's one frequency with a bandwidth, narrow FM or wide FM or whatever. We call those repeaters or FM transponders. You can have what's called a linear transponder, which takes a range of frequencies, and everything adheres in that range of frequencies. It copies to another range of frequencies, usually in another band. So imagine that you had an HF net and everybody transmitted on 15 meters and listened on 10 meters. That would be like a linear transponder. You could have CW down at the bottom of the band. You can have guys sending slow scan in the middle. And you can have sideband conversations up in the top end of it. So those are our linear transponders. Sometimes you'll hear those called bent pipes. Boy, we're cruising through this. Doppler effect. Everybody know what Doppler effect is? Remember when they teach it in school? Right. They talk about a train or an ambulance with a siren coming at you. As it comes at you, the frequency seems higher, and when it goes by, it drops as it's going away. That's sound. That's Doppler effect in sound. And that happens because the relative motion between the 2 points compresses the wave as it's observed, and as it's moving away, it stretches the wave out. So when you compress a wave, you make it higher in frequency. When you stretch it out, you make it lower in frequency. That happens with radio waves too. You don't hear it on Earth very often, unless you're getting lit up on the interstate by the highway patrol, because that's how those work, is Doppler shift most of the time. But you have to have either high frequency or high velocity to hear it on radio waves. Satellites in orbit have high velocity, and we're working with some pretty high frequencies, so you have Doppler shift. Again, as it comes to you, the frequency increases. As it moves away, the frequency decreases. So now we talk about amateur satellites. Everybody's heard Oscar. When I say AO95, the O is for Oscar. AmSat Oscar 95. And Oscar just means orbiting satellite carrying amateur radio. And AmSat will give the owners of satellite an Oscar designation if they ask for one, because it's easier to reference them by numbers than it is by names, and especially in foreign languages. And so it's normally a combination. AmSat Oscar, EO88 was EO80 was European Oscar, FO-29 is a Japanese satellite. They asked for Fuji Oscar. Matter of fact, we just gave 2 new ones out last week. Fuji Oscar 98 and 99. The Russian satellites, which they're not really launching too many lately, they don't participate. Those are RS whatever, and I think they're up into the 40s now. But they haven't put a transponder on anything in 20 years, so sort of irrelevant. All right, we got a couple minutes still. So we're going to talk about easy sats. I'm not real fond of the term, but it's caught on. Easy sats are satellites you can go out and work with a minimum amount of equipment, and they're considered the entry-level satellites. Most of our satellites right now could be considered easy sats. The FM satellites, because FM is real tolerant of frequency, not being exactly on frequency, you can tune the Doppler in a few discrete steps, and it makes it much easier. Those are the easiest of the easy sats. That's what we'll talk about.
CubeSats. CubeSats are the hottest thing in the last decade or two. Some of the first amateur radio satellites were pretty big, the size of a microwave, maybe a washing machine, heavy. The CubeSat standard is a 4-inch cube, basically a drink coaster size. So this is called a 1U CubeSat, 1 unit. It's actually 10 centimeters, pretty close to 4 inches. And then the antennas often deploy off it. I'm going to pass this around just for people to see the size. Some of the solar panels are peeling off. Be careful with that.
It costs $5 million to launch that?
No, $5 million to launch a 150 kilogram satellite. That satellite weighs no more than 1.3 kilograms to a high orbit. Higher is more expensive. To launch one of those to a low orbit is around $100,000. Still a deal. That is for a long while was the smallest satellite available, and I'll tell you why they built these this way. You guys all ever have Pez candy? Remember the little candy dispensers with, Bugs Bunny head on them? Well, we'll get back to that in a second. Launching satellites that small means you're a secondary payload. You're not going to go buy a rocket. A Falcon 9 costs about $60 million and has, I think it's 4,000 kilograms to LEO, something like that. AmSat's not going to go buy one of those. So we're not a first where they used to launch us for free because nobody built little satellites. And they'd rather launch us than a chunk of concrete to balance the rocket out. Now, that space is sold by secondary launch aggregators and satellites for things like the Internet of Things and ship tracking and wildlife tracking and data relay are all paying for that space. So, if you're Boeing or L'Oreal or whoever, and you've got a $100 million communication satellite sitting on top of a $60 million rocket, how enthused are you going to be about a kilogram of space junk that some guys built in their garage sitting underneath your rocket? Not at all. So as more people started launching small satellites, this standard was developed because they could take a tube and put a big spring in the bottom of it with a pusher plate. And it started out 3 at a time. And you load 3 of these 1U CubeSats in it, push it down, shut the door, click, and it's a giant Pez dispenser. Okay? Satellite takes off, $100 million satellites deployed, rocket fires some engines and backs away from it, gets, drops down a little bit so you're not deploying stuff into the same orbit. And the little door opens on the P-pod. That's what they call the big Pez dispenser, the first one. Door opens up and it goes chook, 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 and kicks out our 3 1U CubeSats. So that's basically how we get these launched, is in big Pez dispensers. Now, when it first started out, it was called a P-Pod, the only one there was, and it was 3 of them at once. And then they bolted 12 of them together and made a big unit. AO85, this satellite, was our first CubeSat. And we launched in that big bucket of Pez dispensers. It was called the NPS CUL, or NPS Cool. And they took us on an Atlas V and bolted us right next to the engine on the top stage. So we rode right next to the engine all the way to orbit and made it and worked, mostly. So now, if you look at pictures of satellite launches to LEO, low Earth orbit, you'll see the big satellite up top, and then you'll see usually a bunch of blue boxes. The blue boxes are from a company in Europe called ISIS, probably the worst choice of a name. They predated the other guys. And the sad part is, they split their company in half and had another company for launches. Guess what they named it? ISIL. Yeah. I know a couple of the first employees of the company, and they just, no, we're not them. It's a Dutch company. Anyways, all their dispensers are called ISIS pods, which I think is kind of funny because ISIS pods are little boxy animals on the seafloor, and they're blue. So whenever you see a picture of a launch vehicle being ready and they're setting a big satellite on top, look for the blue boxes on the bottom. So I told you I wasn't going to follow the slides very well.
That's time.
All right, 28 is when it comes over, so I'm going to go for another minute or two. So we talked about this, P-Pods. Now, after the first couple of generations of 1U satellites, somebody thought, well, we could build a little bit bigger of a satellite and put more stuff in it if we put these together. So they started launching 2U and 3U satellites. And the 3U satellite is about the size of a loaf of bread. Now they're up to 24U satellites, and they just make them in big boxes. There was even one launch. There was 2 4Us in the shape of an L, and they fit together. It's crazy. Not the best satellite geometry for some things, but for other things it works pretty well. So this is the Kibo Deployer, which is like a P-Pod, and it is on the ISS. And here's 2 3U satellites. Those look like Planet Labs imaging satellites being deployed. So now we're putting them on rockets. We ship them up to the ISS. They load them in the Kibo, and the Kibo goes out the airlock and shoots them out in a nice low orbit, so they don't stay out there very long. So AO85 was our first CubeSat that AmSat ever built. Our previous satellite was about 10 and a half, 11 inches cube. There's the alarm. Let's go outside.
Kilo 4, Kilo Delta Romeo from KO4MA. Roger, Fox Mike 17, we're in Echo Lima 87 in St. Pete, Florida, over. K4KDR from KO4MA. Okay, thanks a lot. I appreciate the contact. 73 from Florida. CQXW2A from Kilo Oscar 4, Mike Alpha, Echo Lima 87. November Juliet 4 Yankee from KO4MA. Hey Matt, glad you found us. I heard you down the bottom of the band earlier. We're over at the SPARC Club giving a demo. Got a good crowd here. Over. Okay, thanks a lot. Looks like we're getting kind of low to the north, and I don't want to point at the people watching me, so 7373, and thanks a lot for the contact, KO4MA. Okay, I don't want to point this. I'm only running about 10 watts, but yeah, UHF.
Yeah, really good. Fantastic. Thank you, Drew.
So, 6 of them have transponders like that on it. That one actually has propulsion and dropped its orbit as an experiment. That is the lowest, one of the lower transponder satellites that you can talk through. That's why the Doppler, especially when it was right overhead, moved really fast. Like from the beginning when I talked to when I ended, it moved a couple of kilohertz. That's because it was right at the maximum delta in coming and going. So the Doppler shift is the max right overhead or directly east or west of you, middle of the path. Time of closest approach, TCA. That's the word for it. Yes, sir.
Do any of these things ever run into one another?
Um,
I know there are a great number of them up there.
Knock on wood. We've never had an AmSat satellite hit somebody else that we know of or out of the wind to help bring things in faster. And it will also have up to 10 gigahertz on the downlink. We're flying the same transponder that's in Fox 1E will go into all satellites, but then we also have an SDR system where we can go up on any band, VHF, UHF, 3 centimeters, and come down on any band up to 10 gig. You think 10 gigahertz? Well, it's going to be fun, but it's not expensive because satellite broadcast TV is just right next to the 10 gigahertz band. So you buy a $20 Chinese LNB and use a $10 SDR receiver, $20 RTL SDR receiver. It's been so popular for the last couple of years. We put a receive station together for less than $100 for 10 gigahertz. So we're going to try that out. I'm about done, folks. We talked about the elk and the arrow. I'm going to edit this. This antenna is not very good. It's cheap, but it's not very good. The WA5 BJV cheap Yagi works a lot better. Egg beaters. Don't do it. That's a $600 antenna set system right there that you need to put preamps on to get it to work at all. I bought 8 rotors from Lowe's on clearance for $30 a piece. Put a rotor right here, and you get a couple of junk box, 3-element, 2-meter antenna, 6-7 element, 70 centimeter antenna. Tilt them up 15 degrees, and just point them in azimuth. Works better than that any day, and it's the same space for a third of the money. Say no to egg beaters. That's it. Questions? Yes, sir.
Okay, Dave, just real quick, you just talked about don't do the antenna that you said you put with the coat hangers. Okay, so I've done that and I can hear if it doesn't work. So is on AmSat side, is the fix to that on there? Is it change the polarity of the cross polarization or what?
Okay, you got egg beaters, you said?
No, not egg beaters, but the one before the egg beaters, you know, where it just looks like a long, like a 1x2 or something, you put the coat hanger.
Yagi.
Yeah, the Yagi on there. You said don't do that?
No, don't do the egg beaters.
No, I'm sorry, the one before that you said is okay?
Oh. This
Yeah, that's
guy,
the one, yeah.
$4 ham radio satellite antenna.
Yeah.
This will work on high pass in a noise-free environment. Part of the problem is that the depending on, there's a lot of interaction between these. You know, you're putting a 70 centimeter antenna within the field of a 2-meter antenna that's also resonant as a 3/4 wave on 70 centimeters. It's a good idea, but it just doesn't work out very well. Build 2 antennas, put them on 2 separate booms, feed them with 2 separate coaxes, and use a diplexer. Or you can build WA5 BJV that uses a hairpin match. It was designed to be tolerant of different lengths, you know, not tolerant of imprecision. How's that? put it on the same boom with 70-centimeter one. Like I said, I didn't make this slide deck. Yes, sir.
How do you keep a CubeSat in orbit?
Same way anything else stays in orbit. Buddy, I'm almost done. They'll stay in orbit until the drag overcomes the inertia they have. And then they come in. And they're designed where nothing is large enough or hard enough not to burn up before it hits the ground. That's a safety thing. No. Go sit down. Yes, sir.
Are any of the ones with linear transponders work on FM or is it flat-band only?
A linear transponder will pass FM. And if you do it, you're likely to find your coax cut.
It's a good broadband, right?
Well, it takes all the power. It's 100% duty cycle. So if you key up on FM on a transponder and you've got the strongest signal, no one else is using the transponder. So in places that do not have much sideband gear, India, for example, they launched a satellite about 10 years ago, and they allow people to use FM on the transponder. Will not fly over the U.S. You'll be getting letter bombs and check under your car for cut brake lines before you leave in the morning. Technically, yes, it'll work, but socially, no good. Any other questions? Yes, sir.
How important, what would be the limitations to a station without elevation control?
So, there's a couple of things important about that. Satellites spend most of their time low on the horizon. Bob Berninga did a plot using the GPS satellites, I think it was, or maybe it was the ISS. And I think it was like 80% of the time they're below 30 degrees. If you take a pair of short Yagis that have a wide beam width to begin with, you know, within 3 dB, and their beam width is 45, 60 degrees, something like that. And you think about it, if you tilt them up a little bit, you're going to cover from 0 to 60 degrees elevation within 3 dB. And just pointing an azimuth. The satellite's not going to spend much time overhead. Most of the time as it's coming up, it's slow, it zips overhead relatively, you know, perspective. And then it slows down as it's going away. Or it's off to either side. That was an overhead pass. A lot of passes are low on either side. The other thing that works in your, so one thing that works in your favor is that it doesn't spend much time up here. So if you're not hearing well, it's not going to last long. The other thing is when it's directly overhead, it's much closer. And there's less path loss, so it's stronger. So that helps make up for lack of gain right overhead. It's not perfect. You're going to have some, you'll miss some things once in a while. But all in all, having some gain and being able to point it in the general direction of the satellite is better than having something like an egg beater with no gain that's circular overhead and horizontal on the horizon and just stinks in any direction. Make sense? Other questions? Karsten,
Can it pass this around?
you can walk around with it, just don't poke anybody with it, okay? You're welcome to feel how light the arrow is. That all breaks down too and packs up in a little thing about that big. Yes, sir.
How do you fund all this? Where do you guys get money? Is this from the ARRL or?
Oh, I wish. The ARRL has made donations in the past, generally to ARIS, the space station program. The last, I think they made a donation for AO51. But in general, AmSat is a membership-driven organization. Membership is $44 a year. We have a journal that we do 6 times a year. It's got lots of good stuff in it. This is about 30 pages. We're about to go electronic on this, I think. Costs a lot to mail dead trees around these days. So the electronic will be full color. We'll pass that around too. But yeah, we'll wrap it up here. We're membership driven. So if you get into satellites and you like it, join up. if you don't wanna join up, send us a couple bucks. We do recurring donations. We give things away, for, different levels of donations. And this is all comes from other ham funding, you know. Occasionally, we'll get a grant from, an estate that helps out. We have a couple of big donors that, sustain us. You know, it's no bucks, no Buck Rogers, as Dr. Clark says.
So who's actually making these satellites?
We are
So where is it being?
all over it. The engineering team is probably a core of about 50 hams. A team will take on a board. You know, a team will. We had two twin brothers that built the maximum power point tracking power supply for the Fox satellites. They started it as a college project, and they built 3 of the 4 power supplies in their living room. It all gets tested. Some of the boards are prototyped and then professionally assembled, like the IHU, the computer board, because you got something the size of a postage stamp that's a ball grid array with 250 contacts underneath it. You know, we can't build that by hand anymore. So we send that out to be done. And then it all gets integrated in one spot, and then we have to go through testing. We thermal cycle it, go from cold to hot, check for stuff, gases coming off. We do vibration testing, put it on a vibration table and shake the hell out of it until pieces fall off. I hope they don't fall off. All that to meet the specifications for the launch vehicle.
Are you part of the EMI?
No, we're not.
Sure, we're gonna have to wrap it up, but really thank you for a great presentation.
You guys, catch me whenever, drop me an email, ko4ma@amsat.org. Any questions that I can answer,